So this is lithium. It's got 3 electrons, 3 protons, and usually 4 neutrons. And you probably don't think about it very much, right? Show of hands, who doesn't think about lithium? You probably don't think about it very much. You probably know that it's used in a medication, you know that it's used in batteries, and that's it. A couple years ago, I was sitting in my room, very emo and depressed, and listening on repeat to the song Lithium by Evanescence. You might, if you're slightly older, know the song Lithium by Nirvana. And it struck me as odd that these 2 intense emotional bands had both written songs about lithium. And this isn't really a thing that happens, right? Okay, people write songs about gold and platinum, but there's no beryllium song. There's no boron song. Why this one? And I started digging, and it turns out that lithium is one of the strangest elements in the universe. And I want to tell you about it, starting with the fact that it probably shouldn't be here on Earth at all. So, you've all heard the phrase, we're all stardust. So what that means is that way back in the early universe, there was a giant cloud of hydrogen gas. And somewhere in that cloud of gas, a little bit became denser than the rest. And the gravity of that part started pulling it in farther and farther. And as more accumulated, it started pulling in faster and faster. And eventually, the whole thing began collapsing and heating up. And eventually, it heated up to the point where nuclear fusion ignited. And the force of explosion from that fusion counteracted the implosion from gravity. And that's what a star is. And then inside that star, the hydrogen, element number 1 with 1 proton, began fusing with other hydrogen. 1 plus 1, you end up with element number 2, helium. And that went on for hundreds of millions of years. And then eventually, the hydrogen was used up, it stopped burning, collapsed, heated up more to the point where it could fuse helium, element number 2. So 1 plus 1 gave us 2, element 2 plus element 2 gives us element 6. That's right. And that's because of quantum mechanics. The best thing about being a physicist is anytime you want to skip a long, involved explanation, you just go, because quantum mechanics. But so the helium burns into element number 6, which is carbon, as well as 7 and 8, oxygen and nitrogen. And this process continues, and you start creating more and more elements, all of the ones we know up to iron, number 26. And once it hits iron, it can't burn anymore. The star shuts off, and if it's big enough, it collapses more, and as it collapses, it rebounds and explodes as a supernova, the brightest thing in the universe, which can outshine a galaxy while it's exploding. And in the hot plasma from that supernova explosion, it is so intense that all of the heavier elements can be formed from nuclear fusion. All of the gold and the silver and the xenon and the uranium are made there, along with all the others. And throughout this, all these elements are being scattered out into the cosmos. And as they are, they find another cloud of hydrogen gas. And this one begins to collapse into a star, and that star ignites. And around it, now these heavier elements form into rocks and asteroids and planets, and that's what Earth is. And that's why we're all stardust. There are a couple things about this. First, we skipped lithium, skipped number 3. So where does it come from? It's actually even weirder than that. If you had some lithium and you took it and you put it into a star, it would melt and go away. So not only do stars not produce lithium, they destroy it if it existed before. It turns out it comes from a number of places. A small amount of it does come from stars in that supernova explosion and the other ways that stars die. But a lot of it comes from thinking about, what did I mean when I said we're all stardust? It turns out that's not quite right. Because in your body, you're about 10% hydrogen. And if you remember, the star started from a primordial cloud of hydrogen gas. Where did that come from? And that, it turns out, came from the Big Bang itself. So moments after the Big Bang, everything was a hot, dense soup of undifferentiated nuclear matter. Eventually, it cooled, and as it cooled, little droplets of nuclear matter formed, and those droplets became protons, which are the nucleus of a hydrogen atom. And it goes on. During that hot era, the protons can fuse with each other, and they can make helium, and then unlike stars in the early universe, that helium can fuse to make lithium. And it's different there because quantum mechanics. But some lithium is formed in the Big Bang. It's not a lot. It's 1 part in 10 billion, but that's enough. And a lot of that comes into these clouds of gas and ends up here on Earth. And the fourth place that we get lithium from is actually my favorite. It goes by the wonderful name cosmic ray spallation. It's a lovely word. What it means is this. Out in the universe, cosmic rays are accelerated. These are protons and electrons and positrons and other things, and they come screaming across the cosmos. Occasionally, one of them will intersect with the Earth. I say occasionally. There's a tremendous number of these things. We're being bombarded by them constantly. Sometimes these cosmic rays come in through the atmosphere and they find a big nucleus, like a nitrogen or an argon, and they hit that nucleus and they shatter it. And the shattered bits of that giant nucleus form other elements, sometimes lithium. So the lithium we have here on Earth, like us, is part stardust, part primordial dust, and part Earth dust. And now you're probably sitting there thinking, I have thrown a blizzard of sciences at you. I've talked about cosmology and astronomy and nuclear physics and particle physics, and I'm not going to stop. Because now it keeps going. The lithium nucleus binds through electromagnetism to electrons to form the lithium atom itself. And once it's formed the lithium atom, it combines with other elements through chemistry to form compounds. And those compounds get into all the systems in the Earth. They're dissolved in the oceans and evaporated, and they're deposited in salt flats. And some of them get into the underwater waterways. And the geochemistry and geohydrology take that lithium through the Earth and deposit it in certain places, like Bolivia and Chile and Argentina. And it's fascinating how the geochemistry means that it ends up in Bolivia and not, Topeka or Brooklyn. And once it's there and we find those deposits, we can take tools we've made of iron and steel and we can dig it up and use it for things. It's one of the lightest elements that can be used to make a battery, so it powers all of our mobile devices. It also can be used in ceramics and lubricants and fireworks and specialized lenses. It can be used to make tritium, which is important for nuclear fusion, both power plants and bombs. And because of all this technological applications, the geochemistry that deposited it gives way to geopolitics of mining ethics and colonialism. And then we can take some of that lithium and combine it with carbon and oxygen to make lithium carbonate. And we take the lithium carbonate and put it together with a white powder and mill it into pills that we can then ingest. And once they're inside us, they go into our stomach where they're dissolved and enter the bloodstream. And once it's in the bloodstream, the lithium atom moves away from the rest of the compound, crosses the blood-brain barrier, and enters sodium and potassium channels in our neurons. And once it does that, through a process for which I cannot even say quantum mechanics because we do not know how this works, it becomes an incredibly effective medication for certain psychiatric disorders, particularly bipolar, for which it can bring down the highs of mania and lift up the lows of depression. This one atom, number 3, which possibly came from the Big Bang itself, has a profound effect on what we think of as our personality, on our psychology. And this, of course, is why Nirvana and Evanescence wrote songs about it. And I was listening to this and thinking, this changes my view of what my brain is. Right? Now, I'm not a dualist. I don't think that the mind is some special mystic force that's separate from the brain. If you ask me, does the mind come from the brain? I would say, yes, of course it does. I'm a good scientist. But I don't think that. I don't feel that. I'll say things like, my brain hates me, or my brain is making me do this, as if it's separate from who I am. And this is why I like the story of lithium, because it makes visceral something that before I had only known in the abstract, that the same forces that shape our personality are the same as the forces that shape everything else in the universe. And I really like these stories that connect us to the science around us. There's a myth, you probably know this, about Isaac Newton. He's sitting under a tree, and an apple falls and hits him on the head. And as the apple falls and strikes him, he realizes the force that is pulling the apple down, gravity, is the same as the force that's keeping the planets in orbit around the sun. And when he realizes this, he realizes that there is no difference in the laws of nature on Earth and the laws of nature in the heavens. And when he does that, he erases the distinction between the Earth and the heavens, brings the Earth up to the heavens and the heavens down to Earth. Now, that's a myth in 2 senses. First, it didn't happen. Not quite like that. He did see an apple, it did not hit him on the head, and he certainly did not have a complete and sudden realization. But it's also a myth in the sense that it's the kind of story that we tell to explain to ourselves how the universe works, what our place is in it, and how we should live in that world. And this particular myth is really important to scientists, because this is the myth that says, if I do an experiment here and I do an experiment over here, I'm going to get the same answers, that the laws of nature are not capricious. And in that sense, it's the myth that gives meaning to everything that scientists do. And so we keep telling this story over and over again because it locates us in the world. We might not realize that's what we're doing when we tell it, but that's how myths function. We don't normally think of stories about science as being important for our personal identity or our cultural identity. There's a few exceptions, like the debates over evolution or climate change. But other than that, we think the chemistry of lithium, or the biochemistry of lithium even, seems like this very clinical thing that's very disconnected from who we are as people. And that's why I like the lithium story. Again, it makes very visceral this thing that was abstract. And I think if we're serious about living in the scientific world, if we're serious about living in the world that's been revealed to us by science, then we need to be telling more of these stories. We need the story of the atom from the Big Bang that can affect our personality. We need stories that cut across all the different sciences and the humanities, the stories that show us that everything out here really is deeply connected. Thank you.